In this lesson, we'll discuss big idea number 1, what are redox reactions and how do you describe them, and discuss learning target number 1. By the end of this lesson, you should be able to identify when a redox reaction occurs and describe the reaction using proper terminology. And you can represent them using half reactions. Redox reactions occur when reactants transfer one or more electrons. The loss of electrons is called oxidation, where gaining electrons is reduction. A nice way to remember that is Leo says Gur. Loss of electrons, oxidation; gain of electrons, reduction. Since both of these occur simultaneously, their names are combined when describing the reaction type. Hence the name redox reaction. The reactant that causes the oxidation or reduction is referred to as the oxidizing agent or reducing agent, respectively. Remember in grade 11, we learned how to write net ionic equations. Here's a reminder. Balanced chemical equations are not always the best way to represent reactions. Ionic equations show aqueous ionic compounds separated into their individual ions. Spectator ions are removed in net ionic equations, showing only the chemicals involved in the reaction. In order to identify the spectator ions, look for chemicals that have the same amount, same state, and same charge on both sides of the arrow. Here's an example. If I do a single displacement reaction with magnesium and iron 2 chloride, here's the balanced chemical equation. Because the iron 2 chloride is aqueous, really I have iron 2 plus and 2 Cl1 minuses floating around. AQ means that this compound is dissolved in water, which frees up the ions to float around separately. By writing these aqueous compounds as separate ions, this is known as a total ionic equation. Notice that on both sides I have 2 Cl1 minuses that are in the aqueous state. Chlorine ions are spectating. If I remove these from the total ionic equation, I get the net ionic equation. To figure out if a redox reaction happened, ask yourself if electrons have been transferred. I have a magnesium solid turning into an Mg2+ aqueous. In order for that to happen, the magnesium must have lost 2 electrons. I have an Fe2+ changing into an iron solid. That means that iron ion gained 2 electrons to become a neutral atom. Therefore, the magnesium must have transferred 2 electrons to iron. Therefore, it is being oxidized because magnesium has lost electrons. It also caused the iron to be reduced. It was a supply of electrons for it, so it's known as the reducing agent. Because iron accepts electrons, it's classified as being reduced. And because it removed the electrons from the magnesium, it is classified as the oxidizing agent because without its presence, magnesium would not have oxidized. Pause the video here and try out example 2. Is this a redox reaction when lithium reacts with aluminum bromide? And identify which reactant is oxidized and reduced, and which is the oxidizing and the reducing agent. Pause the video until you have your answer. Here's the answer for example 2. First start by writing a balanced chemical equation. Because I have two ionic aqueous compounds in this reaction, I can change these into a net ionic equation. I'll start by breaking apart all the AQ compounds into their ions. Because I have three Br1- aqueuses on both sides, they are the spectators. If I remove those from my equation, I'll get my net ionic equation. Let's see if we have a redox reaction. I have lithium ions going from neutral to a +1 charge. In order to do that, they must have lost an electron each. And then I have an aluminum 3+ going to an aluminum neutral. In order to do that, they must have gained 3 electrons. Therefore, I have a transfer of electrons from the lithium to the aluminum. Because the lithium loses electrons, it gets oxidized. And because the aluminum gains the electrons, it becomes reduced. Because the lithium supplies the aluminum with the electrons it needs to become reduced, it is known as the reducing agent. And because the aluminum accepted the electrons from lithium, causing it to be oxidized, it will be known as the oxidizing agent. Another way to represent redox reactions is by writing half reactions. Half reactions are balanced equations showing an oxidation or reduction separately, including the lost or gained electrons. To do this, write the correct reactant and product, then add coefficients to balance the atoms as usual. Then add electrons so that the total charge on the left side of the equation equals the right side. Let's have a look at example 3. Here I have a net ionic equation showing zinc solid reacting with a copper 2+ ion. Let's first identify what gets oxidized and what gets reduced. The zinc goes from a neutral charge to a +2. It must have lost electrons, and losing electrons is oxidation. To write the half reaction for this, I start by writing down the reactants and the products. And then use coefficients to balance your atoms like usual. Because I have one zinc on both sides, I'm already balanced. Now I add electrons in order to balance the charges. We've already discussed that the zinc has lost 2 electrons, so +2 electrons show up on the product side. In the instructions, I mentioned that you add electrons so that the total charge on the left side equals the right side of the equation, so that the net charges are the same, left side, right side. That's a good way to double check. On the left side of the equation, I have a net charge of 0, On the right side of the equation, I have a 2 plus and I have two 1 minuses. That also gives me a net charge of 0. So I'm balanced. The charges have to be the same. They don't have to always equal 0. Now, if the zinc got oxidized, it means that the Cu2 plus got reduced. Start by writing the reactants and the products. I'm already balanced with one copper atom on each side. Now by adding 2 electrons to the reactant side, I have balanced both sides so that they have a net charge of 0. Pause the video here and try out example 4. This combines both writing a net ionic equation and then changing it into two half reactions. Here's the answer for example 4. Start by writing the balanced chemical equation. Because my cobalt-2 nitrate and my aluminum nitrate are both aqueous, it means that I will break them apart and identify the spectator. The spectator will be 6 NO3 1 minuses. Now my aluminum has a neutral charge and changes to a 3 plus, so therefore it gets oxidized. In order to balance the equation, I need 3 electrons on the product side. Notice that I did not transfer the 2 down. Half reactions need to always be written in lowest terms. If you transfer the 2 down, then you would need a 2 here, a 2 here, and 6 electrons, which then you would just divide by 2 to put it into lowest terms. Because my aluminum gets oxidized, the cobalt will get reduced. And I'll need to add 2 electrons to the reactant side in order to balance the reduction half reaction. Pause the video here and try out example 5. Take this unusual net ionic equation and write 2 half reactions. Here's the answer for example 5. One of these copper 1 pluses has to be oxidized. Remember, oxidation means it loses electrons. If a Cu1 plus loses 1 electron, it will become a Cu2 plus. That means the other Cu1 plus needs to be reduced, gaining an electron. If it does so, it will change into a copper solid. When two atoms of the same element redox each other, it's called a disproportionation reaction. This is a reason why some solutions have short shelf lives and should be used after being made.